Think about the world around us. It's filled with technology. Our phones connect us instantly. Cars drive themselves. We can even print three-dimensional objects in our own homes. It's mind-blowing, really. But have you ever stopped to think about how we got here? How did we go from basic tools to these complex machines? Our story begins long before silicon chips and microprocessors. Imagine a time before electricity, when calculations were done by hand. The earliest computing devices were simple tools designed to aid in these tedious tasks. The abacus, for example, a device invented thousands of years ago, used beads strung on wires to perform basic arithmetic. These early tools may seem rudimentary compared to today's technology, but they represent a fundamental human desire to find ways to make complex tasks easier and more efficient. This desire fueled centuries of innovation, leading to increasingly sophisticated machines. The 20th century witnessed an explosion of progress in computer technology. The development of electronics revolutionized the field, paving the way for smaller, faster, and more powerful machines. The invention of the transistor in 1947 was a pivotal moment, replacing bulky vacuum tubes and ushering in the era of miniaturization. This period saw the creation of the first general-purpose electronic computers. ENIAC, built in the 1940s, was a behemoth, filling an entire room. It was used for complex calculations, including simulations for the hydrogen bomb. These early computers, while impressive, were still largely inaccessible to the public. They were expensive to build and operate, and their use was limited to specialized applications in government, research, and large corporations. But the seeds of change had been sown. As transistors gave way to integrated circuits, computers continued to shrink in size and increase in power. The stage was set for a revolution that would bring computing to the masses. The 1970s marked a turning point in the history of computing, the advent of the personal computer. Companies like Apple, IBM, and Microsoft emerged, driven by a shared vision of making computers accessible to everyone. The Apple II, released in 1977, was one of the first commercially successful personal computers. It was user-friendly, relatively affordable, and it sparked the imagination of a generation. Microsoft's operating system, Mississippi, DOS, which debuted in 1981, further popularized personal computers. This operating system provided a standard platform for software developers, leading to an explosion of applications for business, education, and entertainment. The personal computer revolutionized the way we work, learn, and play. It democratized access to information, empowered individuals, and laid the foundation for the digital world we inhabit today. But this was just the beginning. The story of computing is far from over. Weaving the fabric of connectivity. As personal computers became more commonplace, a new idea began to take shape, connecting these machines together. Imagine a world where information could be shared instantly, where distance was no longer a barrier to collaboration. This was the promise of the Internet. The origins of the Internet can be traced back to the 1960s, with the development of ARPANET, a project funded by the US Department of Defense. This early network was designed to connect researchers and military installations, allowing them to share information and resources more efficiently. At its core, the Internet was about communication, about breaking down barriers and fostering collaboration. It was a network built on the idea that sharing information freely would lead to innovation and progress. In the beginning, the Internet was primarily the domain of academics and researchers. It was a complex and often unwieldy system, requiring a certain level of technical expertise to navigate. But as the technology matured, so too did the potential for wider use. The development of the World Wide Web in the early 1990s transformed the Internet from a niche technology into a global phenomenon. Tim Berners-Lee, a British scientist, created the World Wide Web as a way to make information on the Internet more easily accessible. The World Wide Web introduced concepts like web pages, hyperlinks, and web browsers. Suddenly, the internet was no longer just a collection of text files and data. It was a vibrant tapestry of interconnected information, easily navigable with a simple click of a mouse. The first web browsers, like Mosaic and Netscape Navigator, made the internet accessible to everyday people. They provided a graphical interface, making it easy to navigate the web and view content. The internet was no longer the exclusive domain of scientists and programmers. It was open to everyone. The internet's impact on society has been nothing short of profound. It has broken down geographical barriers, connecting people from all corners of the globe. It has democratized access to information, making it possible for anyone with an internet connection to access a vast library of knowledge. Social media platforms emerged, allowing people to connect with friends and family, share their thoughts and experiences, and engage in discussions on a global scale. The internet became a powerful tool for social change, enabling people to organize protests, raise awareness about important issues, and hold those in power accountable. The internet has also transformed the way we work, learn, and play. E-commerce has revolutionized retail, allowing businesses to reach customers worldwide and consumers to shop for goods and services from the comfort of their own homes. Online education has made it possible for people to learn new skills and pursue degrees remotely, breaking down barriers to education and creating new opportunities for lifelong learning. The internet has also had a profound impact on entertainment. Streaming services have replaced traditional television and radio, giving consumers unprecedented choice and control over their entertainment options. Online gaming has become a global phenomenon, connecting players from all over the world in virtual worlds. Section 4. The Information Superhighway. The Internet's rapid growth has brought with it new challenges and concerns. Issues of privacy, security, and digital literacy have come to the forefront. Governments and organizations grappled with how to regulate this new frontier, balancing the free flow of information with the need to protect users from harm. The digital divide, the gap between those who have access to technology and those who do not, became a growing concern. Efforts were made to bridge this gap, promoting digital literacy and expanding access to affordable internet service. Despite these challenges, the internet has continued to evolve at an astonishing pace. The development of mobile technologies like smartphones and tablets has made it possible for people to access the internet from virtually anywhere. The Internet of Things, a network of interconnected devices, is transforming how we interact with the physical world. From smart homes to self-driving cars, the internet is becoming increasingly integrated into our daily lives. And as we move further into the 21st century, the lines between the physical and digital worlds will continue to blur. Section 5. The world at our fingertips. The internet has ushered in an era of unprecedented connectivity and access to information. It has transformed how we communicate, work, learn, and play. But the story of computing doesn't end there. In fact, it's just the beginning. The convergence of computing, communication, and information technologies has paved the way for a new era of innovation. Artificial intelligence, machine learning, and quantum computing are just a few of the emerging technologies that promise to revolutionize our world in the years to come. Imagine a world where computers can understand and respond to our needs in ways that were once thought impossible. Imagine a future where diseases can be diagnosed and treated with unprecedented accuracy, where renewable energy sources power our cities, and where space exploration takes us to new frontiers. The journey from the abacus to the smartphone has been marked by incredible ingenuity and a relentless pursuit of progress. As we stand on the cusp of a new technological revolution, one thing is certain: the future of computing is full of possibilities. Section 1. ENIAC, the first giant. The Electronic Numerical Integrator and Computer, or ENIAC, is often hailed as the first general-purpose electronic digital computer. Unveiled in 1946, ENIAC was a monumental achievement in computing. Developed at the University of Pennsylvania, it was designed for the US Army. This behemoth filled an entire room and weighed around 30 tons. It comprised 17,468 vacuum tubes, 7,200 crystal diodes, and 1,500 relays, consuming as much power as a small town. Despite its size, ENIAC performed calculations at unprecedented speeds. It could execute 5,000 additions or subtractions per second. The machine was programmed using plug boards and switches, making it a highly manual process. However, its computational power marked a significant leap forward. ENIAC's impact went beyond its military applications. It demonstrated the potential of electronic computing to a wide audience, sparking interest and investment in computer technology. Researchers began to envision computers as versatile machines. The success of ENIAC paved the way for subsequent innovations. It inspired a generation of computer scientists and engineers. The lessons learned from ENIAC informed the development of more advanced systems, setting the stage for the rapid evolution of computer technology. Section 2. The birth of stored program architecture. One of the most significant advancements in computing came with the concept of stored program architecture. Proposed by John von Neumann, it changed how computers were designed and operated. Before this, computers like ENIAC were programmed manually. Von Neumann's idea was to store instructions in memory, just as data was stored. This made computers more flexible and powerful. The stored program architecture is the foundation of modern computer design. The first to implement this was the Manchester Baby in 1948. Though rudimentary, it demonstrated the feasibility of the concept. Followed by advanced machines like EDVAC and EDSAC. The transition marked a turning point, transforming computers into general-purpose machines. This versatility accelerated technological progress, setting the stage for the computing revolution. Section 3. The dawn of commercial computing. The 1950s saw the emergence of commercial computing as businesses began to recognize the potential of computers. One of the first commercially available computers was the UNIVAC 1, developed by J. Presper Eckert and John Mauchly. Delivered to the US Census Bureau in 1951, it was a significant milestone in computing history. UNIVAC used magnetic tape for data storage, a major improvement over punch cards. Its success demonstrated the commercial viability of computers, leading to increased business investment. Another key development was the IBM 701, introduced in 1952, solidifying IBM's role in the industry. This period laid the foundation for the computer revolution that would transform the world. Section 4. The transition to transistors. The invention of the transistor in 1947 by John Bardeen, Walter Brattain and William Shockley at Bell Labs revolutionized computing. Transistors replaced bulky vacuum tubes, leading to smaller, more efficient machines. This transition ushered in the second generation of computers in the late 1950s. Transistors were smaller, consumed less power, and were more reliable. These improvements made computers more practical and accessible. The IBM 1401, introduced in 1959, was one of the first computers to use transistors. Its modular design allowed for easy upgrades and customization. The transition to transistors marked a significant leap forward in computer technology. It laid the groundwork for rapid advancements, including integrated circuits and microprocessors. Section 5. The era of mainframes. IBM's System 360 revolutionized computing in the 60s and 70s, making large-scale data processing and time-sharing possible. Section 6. The rise of the integrated circuit. Integrated circuits pioneered by Kilby and Noyce shrank computers and costs, leading to the microprocessor revolution. Section 1. The rise of the personal computer. The 70s saw personal computers emerge, democratizing technology and empowering individuals. In 1975, MITS released the Altair 8800, sparking the personal computer revolution. Hobbyists like Jobs and Wozniak, inspired by the Altair, would go on to create Apple Computer. In 1977, Apple released the Apple II, a user-friendly, fully assembled computer that revolutionized home computing. Its success established Apple as a major player in the personal computer market. In 1981, IBM entered the personal computer market with the IBM PC, legitimizing the industry. Microsoft's MS-DOS became the standard operating system, paving the way for its dominance. Section 5. The Graphical User Interface, a window to a new world. Xerox PARC's GUI inspired Apple's Macintosh, making computers more accessible with intuitive interfaces. Section 6. The Power of the PC, unleashing creativity and innovation. The personal computer revolutionized business and personal life, fostering creativity and innovation. Section 1. A network of networks. The Internet, born from decades of research, connected the world, transforming communication and culture. Section 2. The modem's song, connecting to a new reality. Dial-up modems in the 90s connected people globally, despite slow speeds and technical limitations. Section 3. Email. The digital letter arrives. Email revolutionized communication, enabling instant global contact and laying the groundwork for social media. Section 4. The browser's dawn, navigating the information superhighway. The World Wide Web democratized access to information. Invented by Tim Berners-Lee in 1989, the web linked documents using hypertext. He developed HTML and HTTP, enabling web pages and communication. The first browser, World Wide Web, was released in 1990. Mosaic, a graphical browser, launched in 1993. Mosaic's release sparked the dot-com boom. From dial-up to broadband, the need for speed. As the web grew, so did the demand for faster internet. Dial-up modems were quickly becoming a bottleneck. The race was on to develop faster connections. Broadband offered significantly faster speeds. The increased speeds transformed the online experience. Streaming audio and video became a reality. Broadband had a profound impact on internet use. Section 1. The world in your pocket. The smartphone revolution. The 21st century ushered in a new era of computing, defined by mobility and constant connectivity. The internet, once tethered to desktops, became omnipresent with the rise of the smartphone. The smartphone packed the power of a personal computer into a pocket-sized device. It was a convergence of technologies that profoundly impacted how we live, work, and interact. The revolution truly began with faster processors, efficient batteries, and mobile internet access. Section 2. Apps, the building blocks of a mobile ecosystem. In 2007, Apple released the iPhone, redefining the smartphone market and ushering in the era of the app. The iPhone captivated consumers with its sleek design, intuitive interface, and potential to run a wide range of apps. Apps transformed the smartphone into a versatile tool for games, navigation, finances, and health. In 2008, Apple released the iPhone SDK, allowing developers to create and distribute their own apps. The App Store became a vibrant marketplace for mobile software. The launch of the App Store in 2008 marked a turning point in the mobile revolution. For the first time, users had a centralized platform for discovering and downloading apps. It was a game changer for developers, providing a direct channel to millions of users. Success was determined by app quality, not marketing budgets. The freemium model, offering basic functionality for free, gained popularity. Google launched its own Android market, later renamed Google Play, in 2008. Apple and Google now control the dominant mobile operating systems and app stores. While apps were transforming how we use smartphones, another technology was quietly revolutionizing the mobile experience: GPS, or Global Positioning System. GPS, originally developed for military navigation, uses a network of satellites to pinpoint a device's location on Earth with remarkable accuracy. The integration of GPS into smartphones was a game changer. Suddenly, our phones weren't just communication devices. They were digital compasses, guiding us through unfamiliar cities, providing real-time traffic updates, and connecting us with nearby businesses and services. Location-based apps, from mapping services like Google Maps to ride-hailing services like Uber and Lyft, became an integral part of our daily lives. GPS also enabled a wave of social and location-based games, like Pokémon Go, which blended the digital and physical worlds in new and engaging ways. Fitness apps use GPS to track runs and bike rides, providing detailed data on pace, distance, and calories burned. Social media platforms integrated location services, allowing users to share their whereabouts and connect with friends nearby. The integration of GPS into smartphones transformed our relationship with location, making it an integral part of the digital experience. It blurred the lines between the physical and digital worlds, creating new possibilities for social interaction, commerce, and even personal safety. We've traveled from the abacus to the App Store, from the whirring of mechanical calculators to the sleek touchscreens we carry in our pockets. It's been a journey of remarkable progress, driven by human ingenuity and a relentless desire to push the boundaries of what's possible. And as we stand at the cusp of a new technological era, one question looms larger than ever: what's next? The answer increasingly seems to lie in the realm of artificial intelligence, or AI. No longer the stuff of science fiction, AI is rapidly becoming a part of our everyday lives. Algorithms curate our social media feeds, personalize our shopping recommendations, and even help to diagnose diseases. Self-driving cars, once a futuristic fantasy, are now navigating our streets. AI is fundamentally changing how we interact with technology. Instead of programming machines with explicit instructions, we're now teaching them to learn from data, to recognize patterns, and to make decisions with minimal human intervention. This shift has profound implications, both exciting and unsettling. The potential benefits of AI are vast. It holds the promise of automating tedious tasks, accelerating scientific discovery, and even addressing some of the world's most pressing challenges, from climate change to disease eradication. But realizing this potential requires careful consideration of the ethical and societal implications of AI. Algorithms govern how AI systems process information and make decisions, influencing our lives. They determine what news we see, what products we buy, and who we connect with online. This influence is often subtle, operating beneath our awareness. Algorithms can be powerful tools for good, but can also perpetuate biases. If trained on biased data, algorithms produce biased results. For example, facial recognition systems can be less accurate for people of color. This raises questions about fairness, accountability, and transparency in AI. The rapid pace of AI development presents us with a host of ethical dilemmas. As machines become increasingly sophisticated, blurring the lines between human and artificial intelligence, we're forced to confront questions that were once relegated to the realm of science fiction. One pressing concern is the potential for job displacement. As AI systems become capable of performing tasks that were once the exclusive domain of humans, what will happen to the workers whose livelihoods depend on those jobs? Will we see mass unemployment, or will new industries and job categories emerge to absorb the displaced workforce? Another ethical consideration is the use of AI in warfare. Autonomous weapon systems, capable of selecting and engaging targets without human intervention, raise troubling questions about accountability and the potential for unintended consequences. Who is responsible if an autonomous weapon system malfunctions and harms civilians? Can we or should we delegate life or death decisions to machines? These are complex questions with no easy answers. They require careful consideration by ethicists, policymakers, and the public at large. We need to establish clear ethical guidelines for the development and deployment of AI, ensuring that these powerful technologies are used for the benefit of humanity, not to its detriment. The journey from ENIAC to AI has been extraordinary. We've witnessed a technological revolution transforming our world. AI, robotics, and biotechnology will reshape our world. The challenge is to harness these technologies for humanity's benefit. We must be mindful of AI's risks and embrace its potential. Let's navigate the digital age with wisdom and compassion.